So we're going to finish off this unit with solving quadratic equation word problems. Before beginning, go ahead and set up your notes with quadratic equations, Unit 6A, Homework 7, with the appropriate date in the upper right-hand corner, and then questions and comments on the right-hand side. So one of the most popular quadratic equation word problems is projectile motion. And the general format you're going to find is very familiar. It looks like standard form. And so we're going to talk about what each of these pieces mean. So the negative g is going to be represented by the force of gravity. V will represent your initial velocity, how fast you start out. And then h will be the initial height at which you started. So an object is launched directly upward at 64 feet per second from a platform 80 feet high. What will the object's maximum height, and when will it attain this height? So a couple of things. Number one, they didn't give me an equation, so I need to go ahead and create my equation based on the pieces I was given. So once again, since it doesn't give us gravity, we know that gravity is a given. If we're talking about feet, we'll use the 16. If we're talking about meters, we'll use 4.9. Because this problem is using feet, we're going to talk about using 16 to go into our g. The initial velocity is 64 feet per second, so our v value is going to be 64. And then the platform was 80 feet high, so we're starting at an initial height of 80. And so here's what my equation would look like plugging in the values. 16 for my gravity, 64 for my initial velocity, and then 80 for my initial height. Now, the question is, what am I solving for? Am I solving for the x-intercepts here? What do they want? What will be the object's maximum height? When will it attain this height? Now, the key word here is maximum. If we think back to everything we've learned this unit, especially vocabulary, there is a key word that we're looking at, and it's maximum. And that usually refers to the vertex of the parabola. Now, because this is a negative a value, I know that my parabola is going to open down. And I'm going to be looking for that maximum height, or the vertex. So I want to go back to where I'm going to be using negative b over 2a to find my x or my h value of the vertex. So go in, find your b value of 64, your a value of negative 16, plug it in using parentheses, and then simplify. Now I'm going to get an h value of 2, and don't forget h is represented by t here, so that 2 is going to represent my time. So next, I want to go ahead and plug my 2 back into the equation to get my height. Once again, using parentheses when I plug it in, simplify, and I get 144. So my k value, or my y value, is 144. So as I'm looking at this, I know that 2 represents time, 144 represents my height. Time is in seconds, height would be in feet. So my vertex is 144, and my maximum height would be 144 feet, and it took me 2 seconds to reach that height. Go ahead and take a moment, pause, copy, before continuing on. Make sure you have any questions or comments in the right-hand side of your paper to ask when you come to class. So another example, I have an object that is launched at 19.6 meters per second from a 58.8 meter tall platform. When does the object strike the ground? So remembering that I've got to write my equation, I need to go ahead and figure out, am I using 16 or am I using 4.9 for my gravity? I go back to my equation, I look, I notice that they're using meters for everything else. So I want to go ahead and use a 4.9 for my gravity. So I'll plug that in as my a value. And then 19.6 is going to be my velocity. And then 58.8 is going to be my initial height. So go ahead and plug it into my equation, and I get y equals negative 4.9x squared plus 19.6x plus 58.8. Now the next question is, what do I do with this? What am I looking for? It says, when does the object strike the ground? Well, keep in mind, ground is going to be represented by the x-axis. So I'm looking for my roots. So I want to go ahead and use the quadratic formula to help me here. One of the reasons I chose it is because this doesn't appear to be easily factorable because of the decimals, and the quadratic formula is going to be my best bet when solving on this part. So I want to go ahead and pull out my A, my B, and my C. And then once again, plug these into my quadratic equation using parentheses. Now all I need to do is simplify my three pieces. And this is where we're going to differ just a little bit from what we did with the quadratic formula. Because here I'm actually looking for a specific number, I want to go ahead and simplify this all the way down even if it's a decimal. So break it into its two pieces. I know this is not a perfect square. And I'm going to get negative 19.6 plus the square root of 1172.08, all divided by negative 9.8. And that's going to give me about negative 1.5 if I round to the nearest tenth. Now here's the problem. This is what's known as an extraneous solution. Keep in mind, I'm asking when does the object strike the ground? How long does it take? And when we're talking about time, I can't have a negative time. So this would be known as an extraneous solution. I can't use this part of my solution. So I'm going to discount this part of my solution and move on to my second part, or the subtraction part of my equation, and see if that will give me something I can use. So now that I've got this set up, once again, simplify for one number up top divided by the denominator, and I get 5.5 rounded to the nearest tenth. Now this I can use. So that 5.5 represents how long it took before the object struck the ground after being launched. So here's what I want to talk about. It took 5.5 seconds to strike the ground after the object took off. Once again, thinking about what the extraneous solution means, it means negative time, and we can't have negative time within the parameters of this situation. Go ahead and take a moment, pause, copy before continuing on. So we've talked about velocity and gravity and those types of problems when you're launching something or throwing something. Now I want to talk about some more generalized problems we could come across with regards to a quadratic equation. The products of two consecutive negative integers is 1,122. What are those two numbers? So the first step I have to think about is product. I'm multiplying two things. And specifically, I'm multiplying two consecutive negative integers. So consecutive means one number right after the other. So we've talked about what these would look like before. N would represent the first number. N plus 1 would represent the second number because it's right after. It's one more up. So first number times second number has got to be equal to 1122. So in order to start solving this, you've got a couple of options here. First option, you need to go ahead and multiply this into the parentheses. Your next option is to go ahead and subtract the 1122 to the other side. Now I have my quadratic equation. Now once again, you can solve this a couple of different ways. I'm going to go ahead and try factoring. Since I don't have an A value, I'm going to go ahead and see if I have any factors and make this really quick about it. And so I set up all the factors of 1122, and I try to find two factors that when one's positive and the other's negative, they're one apart. And I see it right here. 33 and 34, when I have 34 as my positive and 33 as my negative, they're going to add to give me 1 and multiply to give me a negative 1122. So I'm going to have n plus 34 as my one factor, and n minus 33 as my second factor. So once again, with factoring, once I have my factors, I'm going to take them both and set them equal to 0. Once they're both equal to 0, go ahead, solve for n. So now I've got n equals negative 34 and n equals 33. What do I do with these two numbers? Be careful, because a lot of people go, oh, that's my solution. Go back up and see what it's looking for. It says two consecutive negative integers. That means the numbers have to be one right after the other, and they both have to be negative. So when I'm looking at that piece, the negative 34 does work, but the positive 33 is not going to work. That's going to be known as my extraneous solution because I can't have a positive number, I need a negative number. So I'm going to start with negative 34. I'm going to plug it back into my equation. Negative 34 plus 1 is going to be equal to negative 33. Because once again, I'm just finding the second number. If n is negative 34, plug negative 34 in here, and what do you get? So my two solutions to this piece would be negative 33 and negative 34 as my two consecutive negative integers. Go ahead and take a moment, pause, copy before continuing on. So for our final generalized example, you're going to have a 500-foot roll of fencing and a large field. You want to construct a rectangular playground area. I want to know what are the dimensions of the largest yard and what is the largest yard. So notice I'm going to start off with perimeter. Because I have a 500-foot roll of fencing, I know that I'm talking about perimeter. So 2 times the length plus 2 times the width is going to give me a perimeter of 500. I'm going to subtract 2w to the other side, and that's going to give me 2l equals negative 2w plus 500. Divide everything by 2, and then I'm going to have a length equals negative w plus 250. And so now I've got the length of what my field would be. So area equals length times width. And here I'll be able to replace my L with negative w plus 250, which only gives me one variable of w. So here I've got negative w plus 250, and I'm going to be multiplying by w. Let's go ahead and distribute that in. And I get a equals negative w squared plus 250w. Now at this point, I love this piece because you're going to notice you're missing a couple of things. You're missing a c value. But that's okay because I'm not solving for an x-intercept or a root or a solution. Keep in mind, it wants to know what is the largest yard. What are the dimensions of the largest yard? And we're referring to the maximum. So I'm going to be finding the value of a vertex. And I know that it opens down and that it's a maximum because my a value begins out with a negative. And so here I'm going to be talking about the h or the x value, which is going to be represented by w. So negative b over 2a, I want to go ahead and plug my b value in here and my a value in here, and then simplify. And that's going to give me 125 is the value of my width. And once again, you're looking for the maximum or the largest area. So I have my w value. I'm going to plug it back into my equation to get my length value. Simplify. And I get a length of 125. So I have a width of 125 and a length of 125 that represents my maximum value or the largest yard. So the dimensions are going to be 125 feet by 125 feet for the largest yard. Now it says, what is the largest area? Well, I just do 125 by 125. And that gives me 15,625 square feet will be encompassed by this 500-foot roll of fencing. Go ahead and take a moment, pause, and copy before continuing on to your try it out. So for your try it out, you have Janice just dived off a cliff into the ocean in Acapulco while vacationing with some friends. Her height as a function of time could be modeled by this. H of t equals negative 16 times t squared plus 16 times t plus 480, where t is the time in seconds and h is the height in feet. Answer these 3 questions using this equation, and make sure you look back at your different examples in your notes to help you figure out what exactly you're looking for. Good luck, and we'll have the answers next class.